Okay, we roll a die. Well, let's do it this way. The game is played by rolling a die. And costs $5 to play. You win $10 by rolling a 5. $20 for rolling a 6. And nothing for any other row, for any other number. What is the expected value of the winnings? What is the expected, let's set this, what is the expected net winnings? Okay, so this start by doing our table, xp of x. And like I said, if we're playing the game, I would say winnings, let that be your x values. What are the potential winnings here? Well, I could win $10 or $20 or $0, right? With me on that? These are the potential x winnings, 10, 20, and 0. 10. All right, what is the probabilities then? So the probability I win $10. Well, I win $10 by rolling a 5, right? Rolling a 5. So what's the probability I win $10? 1 out of 6. Okay? It's rolling a 5. What's the probability I win $20? Well, that's rolling a 6. Also 1 out of 6. What's the probability I win 0? I get $0 for any other number besides 5 and 6. So that's 1, 2, 3, and 4. Yeah, 4 out of 6. I win $0. Okay? All right. Now let's calculate our expected value. Expected value, you just take each x times p of x. So I do 10 times 1/6, 20 times 1/6, and 0 times 4/6. 10 times 1/6 is 10/6. 20 times 1/6 is 20/6. 0 times anything is 0, isn't it? So this is 30/6. Expected value. That's 5. However, I expect the average winning $5. However, this game costs something to play. So do I win $5? No. I actually have to pay then $5 each time. So isn't my expected net going to be 5 minus 5? 0. Yeah. So yeah, I expect the average winning $5, but I have to pay $5 each time, so I've got to subtract that off, don't I? So I wind up back at square one, $0. The expected net winnings here is 0. Now I bring this one up because what does that mean as far as the game is concerned? Well, doesn't that mean this is a pretty fair game for either side? Neither side is favored. If you expect to average winning nothing, then the player doesn't make anything, neither does the person running the game. So this is called, from a mathematical standpoint, a fair game. If the expected winnings is 0, it's called a fair game. Expected winnings equals 0 is a fair game. Now, Las Vegas would have you think, well, if you just lose a little bit, that's still pretty fair, right? But mathematically speaking, expected winnings is 0. In Las Vegas, all the games are expected winnings favor of the house, right? Just know that going in. But expected value equals 0. That's considered called a fair game. So this one right here is a fair game. Okay? Let's do one more. Then we'll be done. All right, so this game is 3 coins. A game, toss 3 coins. All right, you win $1 for each head showing. You win $1 for each head showing. Easy enough, right? What is the expected winnings there? What is the expected winnings there? Well, since we're doing 3 coins, we could have what? Heads? Let's do the list. Heads, heads, heads. Heads, heads, tails. Or we could do heads, tails, heads. Or tails, heads, heads. For 2 heads and 1 tail, right? Then we could do 2 tails, 1 head. Tails, tails, heads. Or tails, heads, tails. Or heads, tails, tails. Or we could do tails, tails, tails. There's 8 of them. That's our list. So, what are potential winnings here? Well, here I'd win what? $1 for each heads. 1, 2, 3. $3 win. What have I got here? $2? $2, $2. Got a $1, $1, $1, 0. Those are my potential winnings. The potential winnings here for my X column, so what do I write here? 0, 1, 2, or 3, or go backwards if you want. With me? X being the winnings, potential winnings. I'm going to put in the X column 0, 1, 2, or 3, because that's what I could win potentially. Okay? What's the probability of each one of these? What's the probability I win $0? Well, I win $0 this one time, right? 1 out of 8. What about $1? Well, I win $1 3 times out of 8. 3/8. $2, also 3/8. And $3, 1 out of 8. That's my table. Question or concern on that? Okay, so now we want to do the expected value of the winnings. So once I get my table, all I have to do is multiply. Multiply 0 times 1/8, 1 times 3/8, 2 times 3/8, and 3 times 1/8. And add those together. So what does that give me? Well, that's 0. That's 3/8. 6/8. 3/8. Which is, what is that? 3/8, 6/8, 9, 12/8, which is 1.5 or $1.50. So the expected winnings here is $1.50. And again, note there, do I ever win $1.50 in one play? No. I can never win $1.50 because I get $1 for each heads. I don't get half a heads unless it's a funny looking coin. So, but that's right. This is an average. Yeah, this is what I would expect to average. If I played this game multiple times, that would be what I expect to average over many, many times. Long haul average. Now, as a secondary question there, B part, what's the fair price for this game? Huh? 50 cents? Well, the fair price would be the price that would make it a fair game. And the fair game, mathematically speaking, is when your expected value is 0. So what would make my expected value 0?